All right, number 9. That's where we're starting. That's where we left off. Kaylee. What? Thank you. That's literally on video right now. Matthew De La Cruz, stop picking your nose. Oh, you ate it too? That's gross.
That's what's up.
Man. And you're proud of it? Okay. All right.
Oh, Robert, did you fall, bro?
Okay, so 24 degrees is your reference angle. So 9 is the hypotenuse, so we're going to put an H right here. X is the opposite leg, so we're going to put an O right there. Alright, so once we have those two informations right here, remember what we're doing is we're always referring to SOHCAHTOA. These are our definitions that determine if we're going to use a sine or a cosine or a tangent problem. Okay, so if you notice, O is X, there's an O. H is 9, there's an H, so this tells us this is a sine problem. So we're going to set this problem up using the sine function. So we write the abbreviation down, and then next to it we're going to write the reference angle, and once again the reference angle can never be the 90-degree angle. The reference angle will always be one of the two acute angles, and it's typically the one that's given to you, which is 24 degrees. So we're going to go sine 24 degrees. We put an equal sign, and then we're going to put a fraction to the right of the equal sign. Now the fraction is the opposite leg, which is x, over the hypotenuse, which is 9. Okay, so this is our equation that we're going to use, that we're going to, essentially we're going to solve it for x. Now we're going to take this sine 24 right here, and we're going to look on our chart, and we're going to find the 24-degree angle, which we're zoomed in so much you can barely see it. But here's our 24-degree angle, right there. And then we're going to follow it over to the sine column, which is the first column. So 0.4067. So the decimal equivalent is 0.4067 for the sine, a 24-degree angle of sine. That's going to be equal to x over 9, and then we're going to solve this equation. Okay, and the way that I'm going to solve it is I'm just simply going to multiply both sides of the equation by 9. Those 9s would cancel out here on the right side of the equal sign, and that would leave me with x, so x would be equal to 9 times 0.4067. 0.4067, which is 3.7 when we round it to the 10th. Okay, there's number 9. Turn it over, number 10. Okay, so let's start with number 10. So first thing we're going to do is we're going to figure out which one is our reference angle, which we call the theta angle, and that angle is right here. So we're working off of that 64-degree angle right there. Once again, I will write SOHCAHTOA up here. Sine is equal to opposite leg over hypotenuse. Cosine is equal to adjacent leg over hypotenuse. Tangent is equal to opposite leg over adjacent leg. Okay, so the side that has the 42 in it, that is a leg, and it's opposite to 64. So I'm going to put an O right here because that's the opposite leg. The side that has the X in it is a leg, and it has to be the adjacent leg. Okay, so we have information about opposite and adjacent. You can see opposite and adjacent means that we're going to be using the tan function, the tangent function, to solve this. So I write that down, TAN. Next to it, you write the degree of the angle that you're referencing from, which in this case is 64 degrees. You put an equal sign, and then to the right of the equal sign you're going to put a fraction. The opposite leg is the numerator, which is 42. The adjacent leg is the denominator of the fraction, which is x. So there is my equation that I'm going to use. Okay, so now I'm going to go to my table, I'm going to go to 64 degrees, and I'm going to see what the decimal is for a 64-degree angle tangent. So here is 64 degrees, way down here, and you can see that the tangent decimal is 2.0503. So 2.0503 is going to be equal to 42 over x. Okay, now, a quick trick here when you're solving for x, when x turns out to be in the denominator, what this means is that x is going to be equal to 42 divided by 2.0503. Okay, so if x is ever in the denominator, all you have to do is put whatever's here where x is and put x there, and that's what x is going to equal. Use your calculator. 42 divided by 2.0503 turns out to be 20.5. So there's the answer to number 10, 20.5. Okay. All right, moving on to number 11. So number 11, my theta angle, the angle that I'm going to reference from, is going to be 70 degrees right here. Remember, never reference from the 90-degree angle. Okay, where the x is, that is the hypotenuse. So I have information about the hypotenuse. And the 13 side is a leg, and it's opposite of the 70 degrees. So I have an opposite leg, I have a hypotenuse. Notice O and H, opposite leg hypotenuse, tells me I'm going to use the sine function in number 11 to solve for. So I write that down. Abbreviation for sine is SIN. Write the angle measurement next to it, which is 70 degrees. Put an equal sign, and then to the right of the equal sign is going to be a ratio or a fraction. And the ratio or the fraction is for sine is the opposite leg, which is 13, over the hypotenuse, which is x. So that would be the equation that we use to set up to solve for number 11. Now go to your table to figure out what's the decimal equivalent of 70 degrees. So there you can see that, 70 degrees. And then we're going to look under sine, which is 0.9397. So we get 0.9397 is equal to 13 over x. And then once again, here's a trick. If x is in the denominator, that means that we just switch these two values. So x is going to be equal to 13 divided by 0.9397. And then you just solve that out on your calculator. So 13 divided by 0.9397, and we're going to round our answer to the 10th, so 13.8 is number 11. There we go, there's 11. Okay, number 12. Now number 12, we're finding DC. So here is DC. So I'm going to put an X right there. Okay, but now here's the trick in number 13. Before I can find X, I have to find this value right here, B to D. So I'm going to put a Y here, and what we have to do in number 12 is we first have to find Y, and then once we find Y, then that will allow us to solve for X. All right, and in order to solve for y, what you have to do is you have to work with this triangle to help you solve for y. So you can see in that triangle that I just highlighted, the 20 is the hypotenuse. The y is the opposite leg. So using this 54-degree angle as my reference angle, I have opposite and I have hypotenuse. So this tells me I'm going to use sine to solve for y. So I'm going to take the sine, and then I'm going to do it from the 54-degree angle, and that's going to be equal to the opposite leg y over the hypotenuse 20. Okay, so that's my equation that I'm going to use to solve for y. Now I'm going to look at my table, and I'll do it off screen. I'm going to look up 54 degrees and sine, which is 0.8090, and that's going to be equal to y over 20. And now I'm just going to multiply both sides of the equation by 20, and that will give me my answer for y, because these 20s will cancel out. So I'm going to get y is equal to 20 times 0.8090, and that's 16.2. Okay, now that's not your answer, but that's your y value, and you need that. Okay, so we now know y is 16.2. Now what you do is, now we got to find x, which is d to c. So now you're going to jump over and you're going to work with this triangle over here. Okay, so that the triangle that I'm highlighting in yellow. So you're going to work with that triangle, the triangle that I just colored in. Now, we're going to use 28 degrees as that's going to be my theta angle, which is going to be my reference angle. I'm going to use this angle, this right here, which is the opposite leg, and I'm going to use this with the adjacent leg. Jordan De La Cruz, what can I help you with?
Oh, I won't be here next period, so I was wondering if there's any work I need to turn in.
First of all, this is on. You're recording this, so we now know you're not going to be here next period.
Hi, Jordan. Jordan, you're cute.
Jordan, there are 2 Math Excel assignments due.
Okay. Sit night?
They're on that back wall. They're due December 1st.
Jordan, is there anything I need to turn in? Because I'm literally just going to stop by here.
Well, the 2 worksheets from this week.
Okay.
Yeah, but that's it. Okay. So you guys, opposite and adjacent. This is a tangent problem, so I'm going to use tangent to solve for x. So I write down tan, then I'm going from the 28-degree angle, and that's going to be equal to the opposite leg, which is y, but y is 16.2, over the adjacent leg, which is x. So that's my equation now that I'm going to use to solve for x. And once again, I'm getting this information from the triangle that I colored in yellow highlighter. Okay? Using the table, a 28 degrees for tan, its decimal equivalent is 0.5317. That's going to be equal to 16.2 over x. And once again, if x is in the denominator, the trick to solve for x is you just switch these. So that means x is going to be equal to 16.2 divided by 0.5317. Okay, so 16.2 divided by 0.5317 is 30.5. We're going to round it. So there's number 13. X is equal to 30.5. 12, I mean, number 13. Okay, 13 you're going to do kind of the same way as number 12. So you're going to have to use sine or cosine or tangent twice. So notice we're finding k to l. So I'm going to mark k to l as x. All right, but if you notice, k to l is part of this triangle here that I'm outlining in yellow, and there's no values for side jk or side jl. So this problem right now is impossible to solve for x. But if I go over to this triangle right here, which I'm outlining in green, what I have to do is I have to use the green triangle to find j to l. So I'm going to call j to l as y. So really I have to find y first using the green triangle. Then after I find y, then I'm going to use the yellow triangle to find for x. Okay, so here's my reference angle, 51 degrees in my green triangle. Okay, y is the opposite leg, so I'm going to put an O here. 14 is a leg, and it's the adjacent leg. So I have opposite and adjacent, so this is a tangent problem. So I'm going to use tangent to solve for y. Write down tan, put the degrees of the angle that we're working from, which is 51 degrees, put an equal sign, and then tangent is defined as opposite leg, which is y in this case, over adjacent leg, which is 14. So that's the equation that you use to solve for y. Now I'm going to convert a 51 degree angle for tangent into its decimal equivalent, and that is 1.2349. And I got that number just by looking at the table that we have for sine, cosine, and tangent. That is going to be equal to y over 14. To solve this equation, I'm just going to multiply both sides of the equation by 14. That would cancel out those 14s, and we would get y is equal to 14 times 1.2349. 0.2349 and 17.3. So there is y now. Now, that's not my answer, but I do need that. Now I'm going to jump over to the yellow triangle, and I'm going to work from the 72 degree angle, so that's going to be my reference angle, what we call the theta angle. Okay, now if you notice where the y is in the yellow triangle, it's not the opposite side anymore, it's the hypotenuse. So y, which by the way is 17.3, is the hypotenuse. X is a leg, and it's the adjacent leg. So we have adjacent and we have hypotenuse, so this is a cosine problem. So I'm going to write cosine. Then I'm going to write 72 degrees because that's the angle that I'm working from. And the definition of cosine is equal to the adjacent leg, which is x, over the hypotenuse, which is y, but y was 17.3. Okay? So that would be the equation that we're going to use to solve for x in number 13. I'm going to change a 72 degree angle for cosine into its decimal equivalent, which is 0.3090. So 0.3090, that's going to be equal to x over 17.3. And now to solve this equation, all you have to do is multiply both sides by 17.3. And that would be your answer for what? For x. Okay, those will cancel out, those 17.3s, and we get x equals, and 17.3 multiplied by 0.3090 gives me 5.3. So there's your answer to number 13. Okay? All right, number 14. Now, number 14, it's a word problem. So typically, when we're doing these problems with a word problem, it's going to result in a picture, and the picture is most likely going to result in a right triangle picture, okay? So let's read it. A wire is attached from the top of a 30-foot telephone pole to a stake in the ground. If the angle formed by the wire and the pole is 48 degrees, what is the length of the wire? Okay, so when I draw this picture, I'm going to use this bottom part. That's going to be the ground right there. Okay, so I have a telephone pole. So here's my telephone pole. The telephone pole is it's a 30-foot telephone pole, so I'm going to put 30 feet right here. Okay, then we have a wire that's attached from the top of this pole, and then it goes to a stake in the ground. So essentially, here's what your wire looks like. I'll draw it in green. So your wire goes from the top of the pole, and then it goes down to the ground. And there's a stake right there. The stake is kind of irrelevant, but just tells you that that's how the wire is going to stay in the ground. Okay? If the angle formed by the wire, remember this is your wire right here, if the angle formed by the wire and the pole is 48 degrees, so that means this angle right here is 48 degrees. What is the length of the wire? Here's your wire. So I'm going to call that x. So in this problem, hopefully you see, here's my right triangle, right here. There's a 90-degree angle, because the pole makes a 90-degree angle with the ground, and I'm finding x. Okay, so I'm going to use 48 degrees. That's going to be the angle that I'm going to start from. That's going to be what we call our theta angle. That's our reference angle. Okay, the side where the x is the hypotenuse. So that's the hypotenuse. And the side where the 30 feet is, it's a leg, and it's the adjacent leg. Okay, so I have adjacent and hypotenuse, so that's a cosine problem. So you're going to use cosine in order to solve this equation out. Write that down. Then write the angle next to cosine, which is 48 degrees. Put an equal sign, and then cosine is defined as the adjacent leg, which is 30, over the hypotenuse, which is x. Okay, if you're not sure where I'm getting these from, remember I'm always referring back to SOHCAHTOA. So, and that's always telling me which trig function, which trigonometry function I use, sine, cosine, or tangent. Okay, see A and H, cosine. Okay, we're gonna 48 degrees cosine. Its decimal value is 0.6691. So this becomes 0.6691 is equal to 30 over x. And if you notice, when I'm solving this, x is in the denominator. So the trick is, when you get x in the denominator, just switch these two values. So that means x is going to be equal to 30 divided by 0.6691. And when I divide that out, that's going to be my answer. 30 divided by 0.6691 is 44.8 feet. So there's your answer to number 14. 44.8 feet. That's how long the wire is. Okay. Number 15. An airplane climbs at an angle of 12 degrees with the ground. Find the horizontal distance it has traveled once it has reached an altitude of 500 feet. Okay, so to draw a picture of this, we have an airplane up here. Here is my airplane. Don't make fun of my drawing, but that's my airplane right there. Okay, it climbs at an angle of 12 degrees with the ground. So basically what they're saying is, if you tracked the airplane and the line that it flew from the ground up, it climbs at a 12-degree angle. So it's saying that line, so it's basically, picture the airplane taking off right here. It gets airborne, and it's going up, 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 up. It's right there, and it went up at a 12-degree angle. That's what it's saying. Okay, we want to find the horizontal distance. Horizontal is this way. It is traveled once it reaches an altitude of 500 feet. So we need to draw a line that represents the altitude. So the altitude is how high the airplane is up from the ground. This line is my ground here. So that's 500 feet right there. Okay, and we want to find the horizontal distance. So we want to find x. That's the horizontal distance right there. So really, this is your problem right here. You create a right triangle with your picture, and now you're going to use sine, cosine, or tangent. Okay, 12 degrees is going to be your reference angle. We call that the theta angle. And then if you notice, 500 is a leg, and it is opposite the 12 degrees, so that's an opposite leg. I put an O there. Where x is, that's a leg, and that's the adjacent leg. Opposite and adjacent tell me it's a tangent problem. tan. Write the angle, which is 12 degrees. That's going to be equal to, and then we put a fraction. Tangent is equal to however long the opposite leg is, which is 500 in this case, over the adjacent leg, which is x in this case. That's what we're finding. Okay, there's your equation. Go to your table, find out the decimal equivalent for a 12-degree angle of tangent, which is 0.2126. So we get 0.2126 is equal to 500 over x. Okay? And now, once again, if x is in the denominator, the trick is to solve for x, you just switch these two values. So this means that x will be equal to 500. Notice I put x where 0.2126 is, put 0.2126 where x is, divided by 0.2126. Divide that out, 500 divided by 0.2126. That answer is 2,351.8. Okay, so 2,351.8 feet. That would be the horizontal distance of the plane. All right, there we go. There's your worksheet right here. Okay, all right, everybody. Say hi.
Put it on me. Put it on me.
Okay, say hi.
Put it on me. I'm right here. Wait, is this illegal?